Okay, now let's look at these problems that relate to the calculation of moles in a chemical reaction. Okay, the first one is question number 57, which relates to the mole-to-mole factors using a balanced chemical equation. So it's very important you balance the chemical equation and always check it. So there are 4 moles of phosphorus here, and there are 2 times 2 is 4 moles of phosphorus. 5 times 2 is 10 moles of oxygen. 2 times 5 is 10 moles of oxygen. Okay, now write the mole-mole factors. So here we have, so I'm going to just for the space, let's see how to do this. So here, 4 moles of phosphorus react with, so here's something, I don't have enough space. Let me create a space here first. Okay, so now we have the mole factors of each. So what we're going to do here is we're going to look at the relationship of phosphorus and oxygen. And we're going to look at the relationship of oxygen with P2O5 and P2O5. And we're going to look at the relationship of phosphorus and P2O5. Okay, so how will we do this? So we see that there are 4 moles of phosphorus reacting with 5 moles of oxygen. And on the other hand, 5 moles of oxygen. So you write this 5 moles of oxygen over 4 moles of phosphorus. 4 moles of phosphorus. Okay. Next is 5 moles of oxygen. So later on, you don't even write the moles. You just write down here 5 moles of oxygen are producing 2 moles of P2O5, and 2 moles of P2O5 over 5 moles of oxygen. So that is the relationship between, each 5 moles of oxygen. Next is 4 moles of phosphorus, 4 moles of phosphorus over 2 moles of P2O5, 2 moles of P2O5, and 2 moles of P2O5 over 4 moles of phosphorus. All right. So these are the mole-mole fractions, or these are also called the mole-to-mole ratio. Mole to mole. Mole-to-mole ratios. Okay, of each of the entity. All right, so that was one question. Next is how many moles of water form when 2.5 moles of oxygen react. So here we are going to look at the relationship between water and oxygen. Okay, it's very important to balance the equation, but you always, look at for the mole-to-mole fractions, it's always only the 2 entities. All right, so here we will write down. So we are looking at the oxygen and H2O. And the relationship is 1:2. Okay. Now, how many moles of water form? So we need to find the moles of water. So always write down what do we need. So moles of water we need to find when 2.5 moles of oxygen are. So we are given 2.5 moles of oxygen. All right. So here you write down the given 2.5 moles of oxygen multiply by. Now here is going to be a mole factor in which the moles of oxygen cancel out. So we know that 1 mole of oxygen produces 2 moles of water. 2 moles of water. So you need to find the moles of water, right? So here, when you do that this way, you cancel out the moles of oxygen. moles of oxygen, and you just get the moles of water. So 2.5 times 2, 2.5 times 2 is like 5.0 moles of water, and that is the answer. All right, so that's how you show all the working, and you write down every single, like, the unit. All right, next is the how many moles of carbon monoxide are produced when 1.2 moles of carbon react. So here we are looking at the relationship of carbon monoxide to carbon. So in this case, you are same thing, write down all the things that are given to you. So carbon, relationship of carbon with CO, carbon monoxide. So 5 moles of carbon are producing 4 moles of CO. So let's write the mole factors. So 5 moles of carbon over 4 moles of carbon monoxide. Okay, or 4 moles of carbon monoxide over 5 moles of carbon. 5 moles of carbon. Okay, so these are the 2 mole factors. Now we are given 1.2 moles of carbon, and we need to find the moles of carbon monoxide. So we know that 4 moles of carbon monoxide are produced when 5 moles of carbon react. Okay, so here we will have moles of carbon and moles of carbon cancel out, and you're just left with the moles of carbon monoxide. So it's 1.2 times 4 divided by 5. Okay, so the answer is 0.96. So the answer is 0.96 moles of carbon monoxide. 96 moles of carbon monoxide. All right, so that's the answer. So that's like, mole to mole conversions basically. And now the same thing, you can do the same thing if you're looking at the relationship of carbon with sulfur dioxide, or you're looking at the relationship of carbon sulfide and carbon monoxide, or carbon disulfide with sulfur dioxide, and so forth. So the same process, okay? So it's very important that first you balance the equation and you use that mole factor in which, the entity that you need to find and the cancel. So always the given. This is always keep this in mind since there's space here. So this is what you need to find. This is find goes on the top, and the one that you want to cancel out or remove or convert from, okay, is going to be at the bottom. And this piece is given to you, comes in the question. Okay. And this piece is right here, comes from the balanced equation. Balanced equation. So you need to balance the equation and then sort out from there the mole factors. All right. All right. Let's look at the next question. How many grams of N2O are produced when 57.5 grams of sodium react? So now these are the grams to grams conversion. So let's see if I can move this a little bit up. Okay, just creating some space here. All right, here we have more space now. So here we are looking at the relationship of, so yes, this is a balanced equation. So we are given the sodium, and we are looking at Na2O. Okay, so you always have to look at the question, what is given to you and what you need to find. So here is, we are given 57.5 grams of sodium, and we need to find so 57.5 grams of sodium, and we need to find how many grams of Na2O are formed when you use 57.5 grams of sodium. So here the relationship is 4 moles to 2 moles. So these are the 4 moles of sodium and 2 moles of sodium. Okay, so 2 conversion factors. There are a few things here. One is the conversion factor. Let me use a different this thing. The conversion factor is 4 moles of sodium over 2 moles of Na2O. And the other is 2 moles of Na2O over 4 moles of sodium. Okay, so this is one thing. Next is the molar mass. This is another thing you would need for grams to moles conversions. Remember that mole to mole you didn't need, but anytime you have grams, so this is how you will do. You're going to take the grams of sodium. Let me put this in a different, let me write the strategies later. So let's do the molar mass first. So here the molar mass of sodium. Now from the periodic table, sodium is 23 grams and Na2O is equal to 2 times 23. That is 2 3s are 6, 46 grams. 46 grams and one oxygen times 16, and that is 16. So 46 plus 16, 12, 4, 5, 6, 62 grams per mole. Okay. Now, let's look at a strategy that we're going to follow. The strategy is, let's start with here. You are given the grams of sodium. And you're going to first convert the grams of sodium to moles of sodium. Okay, grams of sodium to moles of sodium. Okay, moles of sodium. How you're going to use, in this case, the molar mass. So molar mass is M. So there's no space. So using the molar mass, then you're going to get sodium moles. Next is you're going to use the mole to mole ratio. Mole to mole ratio is moles of Na2O. Na2O you need to find over the moles, you're going to bring this a conversion factor. Okay, balanced equation. This is going to give you the moles of sodium oxide. Next, you're going to convert it into the grams of Na2O. Okay, so how are you going to do that? In this case also, you are going to go by the molar mass. So this piece also by the molar mass. Okay, now this piece is from here, the balanced equation. Balanced equation. Okay, now let's do this first. Start with given, which is given to you 57.5 grams of sodium times 1 mole of sodium over 23 grams of sodium times mole to mole ratio. The mole to mole ratio from this balanced equation is 2 moles of Na2O. So I'm going to Na2O. It's okay to write it like that, over 4 of Na. And that means the moles. Next is 1 mole of Na2O is in the denominator, and 62 grams of Na2O is in the numerator. Okay, so in this case, you see that the grams of sodium and grams of sodium cancel out, moles of sodium and moles of sodium. So this is the moles, and the moles of Na2O and the moles of Na2O cancel out. You're just left with the grams, the unit, leftover unit. Okay, the rest is just math, and the math is 57.5 times 1 times 2 times 62 over 23 times 4 times 1. And here you get, okay, the answer is coming out to be 77.5 grams of Na2O. That's the answer. Okay, so this is how these problems are done. All right, let's look at the next one, where you are given, and that's the last one in this video, which is you're given ammonia reacting with oxygen, giving you nitrogen and water. So here is the same question. reacting the grams to grams conversion of the like the products to the reactants, reactants to the reactants, those things. Okay, here you're looking at the relationship of oxygen and ammonia. So two reactants. So oxygen and ammonia. Okay, in this case, you were looking at the reactant to the product. The process is still the same. Okay, so what will you do here? So the question is, so write down all the givens. You are given how many grams of oxygen are needed. So you need to find the grams of oxygen when you are given ammonia is 13.6 grams. Okay, and we need to find the grams of oxygen. Okay, so we see the relationship is 4 moles of ammonia. 4 moles of ammonia are reacting with 3 moles of oxygen. Okay, and the next thing is the molar mass. Molar mass of ammonia. Ammonia, NH3, is 1 nitrogen, 3 hydrogens. Nitrogen is 14 and hydrogen is 1. So here you have 14 and 3, 17 grams per mole. Okay, and then oxygen is O2 is 16 times 2. That is 32 grams per mole. That's the unit for molar mass. Okay, so what is the strategy? The strategy is that you are going to take the grams of, so here this is what we are finding. You are going to take the given ammonia. So take the grams of ammonia, convert that to moles of ammonia. How? You are going to divide that by 1 mole of ammonia over the molar mass of ammonia, right? So that's like, you know, let's put it here. So this is going, okay, let's do grams of ammonia, NH3, 2 moles of ammonia. Next is, you're going to take the moles of oxygen over the moles of ammonia. This cancels out the moles of ammonia, the grams of ammonia this way. And then next is, you're going to go to the grams of oxygen. So in this, what are you going to do? In the first case, you're going to, in both the cases, molar mass is going to be used. Molar mass is M. Okay. Here also, molar mass is used. Okay. And how it is used, how it is like set up. So setting up is like this. So here, write down, what is that? 13.6 grams of ammonia, NH3. Okay, multiply that by 1 mole ammonia over 17 grams of ammonia. Okay, and then you multiply that by the mole to mole ratio, which according to the reaction is 3:4. So 3 moles of oxygen over 4 moles of NH3 ammonia. Okay, multiply that by the gram. So 1 mole of oxygen, and here is 32 grams of oxygen, O2. All right, so you will have now grams of ammonia and grams of ammonia cancel out, moles of ammonia and then the moles of ammonia cancel out, oxygen moles and the moles of oxygen cancel out. So I'm not writing, you know, the mole to mole ratio, I'm not writing the moles because of the lack of space, but that's what it means. Okay, so now you have 13.6 times 1 times 3 times 32, divide that by 17 times 4 times 1. Let's see what we get. Okay, so we get, when we do the calculations, we get 19.1911. So all those things. So we need only 3 significant figures. If you just look at the significant figures, here you have 3. And so and this comes out. So we need only 3. So 9. So we can also make it, we will have to round it up. We can make it 19.2. 19.2 grams of oxygen. Okay. All right. So this video ends here. We are going to next look at the problems, which is 75, 77, 85, and 87. All right. Thank you for watching. Bye-bye.